Hi, today we're looking at section 5-2, identifying intercepts. So take out something to take notes on. Remember, you can always pause the video to write your notes. And complete the check it out questions after each of the examples. Our two learning targets today. The first one, I can find the x and y intercepts and interpret their meanings in real-world situations. And B, I can use the x and y intercepts to graph lines. So what are the x and y intercepts? The y-intercept is going to be the y-coordinate of the point where the graph intersects the y-axis. It's important to remember at that point, our x is always 0. And our x-intercept is the x-coordinate of the point where the graph intersects the x-axis. At this point, our y is always 0. So the y-intercept, x is always 0. And the x-intercept, y is always 0. So let's look at this. So here we have a graph. First one, find the x and y intercepts. So the x-intercept is going to be where it crosses the x-axis. It crosses it here at -2. And the y-intercept is crossing the y-axis here at 1. So we'd write those out. So for our graph, we'd write our x-intercept as the ordered pair -2, 0. Again, notice the y value is 0. And for our y-intercept, it's crossing here up at 1, so our x-intercept is 0, or our x value is 0, and our y-intercept is at 1. So write them as an ordered pair can help you remember to set y equal to 0 for your x-intercept, and set x equal to 0 for your y-intercept. Now let's look at B. 5x minus 2y equals 10. Okay, so for B, we have 5x minus 2y equals 10. So to find our x-intercept, again, we set y equal to 0. So substitute 0 in for y. You can also think about this as covering up, since this term is going to go to 0, so we get 5x equals 10. Divide both sides by 5, and you get x equals 2. So the ordered pair is at 2 zeros, the x-intercept. For the y-intercept, again, we set this time x equal to 0. So you can think of covering this piece up here, leaving us with -2y equals 10, because when x is 0, the x term goes to 0. Solving for y, we get y equals -5. So our y-intercept is at the point 0, -5. Now it's your turn. You have 3 check-it-outs to do. Again, if you keep in mind to find the x-intercept, the y term goes to 0. To find the y-intercept, the x term goes to 0. So cover up the variable, make it go to 0, and solve for the variable that remains. Number 2, Trish can run the 200-meter dash in 25 seconds. The function f of x equals 200 minus 8x gives a distance remaining to be run after x seconds. Graph this function and find the x-intercepts, and what does each intercept represent, or find both intercepts. So remember, this is a real-world application. So in this case, you need to keep in mind that our domain and range, the x and y values, are both non-negative values. So we're going to be graphing them in the first quadrant. And in this case, we start with picking our x-intercepts, So we set y equal to 0, substitute that in. So 0 equals 200 minus 8x. Solving for x, we get x equals 25. So we plot the ordered pair 25, 0. And that's right down here. Put that point down. Then we find the y-intercept. So we set x equal to 0. Doing that, we just get y equals 200. So this is our y-intercept at the point 0, 200. And then we just want to pick one more point. So let's pick 5. And so when x is 5, y is 160. So at 5 and 160, we plot that point, connect all 3, and that becomes our line. And the intercepts represent, the y-intercept represents the time Trish has to run at the start of the race. So she hasn't ran any, she's got to go 200 meters. And the y-intercept, or the x-intercept, I'm sorry, represents how long it takes Trish to finish the race, with the distance remaining when she gets down the bottom, the x-intercept. So now it's your turn to check it out. And you have B. So again, as we said, to graph them, you only need 2 ordered pairs. If you do the x and y intercepts, that's great. but go ahead and pick a third just to check your line. Make sure everything is correct in there. And remember, it's quicker, nice little typo, to do that. So here we want to use the intercepts to graph this line described by the equation 3x minus 7y equals 21. Okay, so for this one, let's start with finding our x-intercept first. So again, we set y equal to 0 because it crosses the x-axis. Y must be 0. And so we end up with 3x equals 21. Solving for x equals 7. So we plot that point at 7, 0. Find our y-intercept. We set x equal to 0, leaving us with negative 7y equals 21. Dividing both sides by negative 7, y equals 3. So we plot the ordered pair 0, negative 3. And then we draw a line connecting them. And notice that the line extends past the points. It is a line that goes on forever, both directions. So now let's go ahead and graph this one using the intercepts to graph the line described by the equation y equals negative x plus 4. So you should be seeing a pattern here. Again, we find our x-intercept, setting y equal to 0 is our first step. So 0 equals negative x plus 4. Adding x to both sides, we get the point 4, 0. So we plot that point at 4, 0. Then we go ahead and we find our y-intercept, setting x equal to 0. So we get y equals 4. So we plot that point at x is 0, y is 4. And then we draw a line through those and connect the dots. And again, you can always check with a third number. When x is 3, we get negative 3 plus 4, and that will be 1. So we can just verify that, yep, our line is correct. It's a good habit to get into to verify. Pick another dot, another point. You have 2 check it outs. Bring any questions to class. So to summarize, up to this point, we've been generating ordered pairs. And keep in mind, we need 2 points make a line or define a line. Pick a third point just to make sure your points are correct, that you've plotted them. Finding the x and the y intercepts are 2 points. So you write them as ordered pairs. The x-intercept is where it crosses the x-axis or the graph crosses. Y must always be 0. The y-intercept, x is always 0. And again, it's a little quicker to find the 2 intercept points and to generate a list of ordered pairs. So good luck bringing questions to class. Thanks.